Oh, hello. Welcome to our next session. So, hello, Max and Artur. So they will tell about how they won the silver prize in Kaggle competition. So it's like actually good achievement, and good is not good enough to describe what it is. So my first question, what is Kaggle? So, because not many, however, it's maybe a stupid question for people who listening DS session, but what is it?
So hi, Dmitry, first of all. Can you hear me well?
Yeah, we can.
Sorry, I cannot hear you.
I can hear you.
Hey.
Hello.
Yeah. I can hear you too.
You can hear me. So yeah, I can hear you now. So Kaggle is a platform for data science and machine learning practitioners, and actually I would like to describe it in more details in my presentation, if you don't
mind. Just brief question. Do you have special roles in your team? So maybe someone is writing code and someone is more have mathematician background and writing some formulas and whatever, or
no, actually not really. We simply been working on this together all along.
Okay, and how this work generally look like? So you work together in one room, or you have sessions, or you discuss something via chat? And
we actually have planned on describing it in our presentation, but since you asked, I can quickly tell you. We simply had one server, and we worked on under that server under different users, but using the same code. And so yeah, it was pretty much like that.
Okay, so I don't know if my question is ended. So I just wanted to maybe find something. So understand how is it possible. So I thought it's maybe and who won the competition? So like, is it Google or Yandex or who?
Well, as I just said, I will tell about that too, just a little bit later.
Okay.
So Kaggle is a team platform. So the global purpose of the Kaggle is to learn how to do the data science, and so the teams work here.
So Dmitry, you're asking us questions that we would like to cover.
Okay. So you can start. So it's you now free. So from my questions, and you can start, I think.
Okay. Hi everybody. I'm really glad to take part in such a wonderful event. First of all, thank you very much for inviting me. And today we would like to share with you how our team got a silver medal in Kaggle competition with motion prediction for autonomous vehicles. So let me introduce our team. Artur Nagaev is a data scientist and machine learning engineer at OCO. It's a Russian live cinema service. Previously, he worked as a computer vision engineer at Reliant. It's an autonomous vehicle startup. Also, he's accomplished Kaggle competitor and member of open data science community. I'm a technical architect at Centric Software. It's a product lifecycle management software vendor which has its own artificial intelligence and machine learning based services. I accomplished a machine learning engineer program at Made Big Data Academy. It's a free educational project launched by Mail.ru Group for developing prospective specialists in data science and machine learning. And I'm also a member of Open Data Science community. So we agreed to organize the team of 2 persons, but it was possible to work in team of up to 5 persons. And the name of our team is Top Gear. So let's briefly talk about Kaggle platform and the Lyft competition. So Kaggle is a crowdsourced platform to attract, train, and challenge data science and machine learning practitioners from all over the world to solve data science, machine learning, and even predictive analytics problems. And Kaggle offers both public and private data science competitions. Kaggle has its own ranking system where you can be grandmaster, master, expert, contributor, or novice, and categories of expertise such as competitions, notebooks, data sets, and discussion. Also, it provides Kaggle kernels. It's a cloud-based workbench for data science and machine learning code snippets, public data set platform, and Kaggle Learn platform for artificial intelligence education. The Kaggle community is growing very fast. There are currently over 5 million Kaggle members. This community has already submitted millions of learning models to different competitions. Here you can see there have been 440 closed competitions that already happened, and there are 24 active competitions at the moment, and it's only public competitions. So I would say taking part in the Kaggle competition is an excellent opportunity for data scientists and machine learning engineers to develop their skills and even raise prize money. Also, I would like to add that Kaggle was acquired by Google in 2017. And I believe this company is watching outstanding and prospective Kagglers very attentively. So I think it's enough for Kaggle. Let's talk more about the Kaggle competition organized by Lyft Level 5. It was launched on the Kaggle platform during 3 months, beginning from August 24 to November 26 last year. It was attended by 935 teams with over 1,000 competitors who performed about 50,000 entries. And the main prize was $30,000 in total, as well as bronze, silver, and gold medals. Actually, our initial target was a bronze medal because we joined the competition quite late at the end of October. So we had approximately 1 month to finish everything.
Well, let's be honest, we simply joined when we have started to work on the competition simply 1 week before the end of the competition. So to be honest, it was just about 1 week. Yeah.
Yeah, but we also learned some details about this competition, and I also calculated this time as well. In this competition, the practitioner had to evaluate the supposed position in the area of traffic agents, such as cars, pedestrians, or even cyclists around the self-driving car. And it was required to provide a forecast for the next 5 seconds. The input information was an aerial photo, high-definition semantic map, the position of self-driving car on the map, and the position of other agents on the map at the current moment and the previous 10 seconds. So here you can see that the red rectangle is our self-driving car, and the yellow ones are other traffic agents. Also, you can see how it looks in 3D view on the right image here. So let's go next. How does the self-driving car work? Within the self-driving stack, the first step toward building self-driving systems is perception. It means identifying what's around us. The next two tasks are prediction. It's determining what will happen next, and planning, deciding what the self-driving vehicle is going to do in the future. So let's focus on the prediction task. The forecast should help the self-driving car to predict most precisely the position of the surrounding traffic agents and respond more correctly to their approaching. For example, this self-driving car tries to turn left while another car is approaching from the opposite direction. It needs to determine whether the other car will turn right or continue driving straight and interfere with the left turn. So, what's the final purpose of such activities? I think you already realized that the end users are the passengers who will be able to choose self-driving option when ordering a taxi in the mobile app, as you can see here. You know, the pilot programs based on Aptiv in the right page image and Waymo technologies have already been running in Las Vegas and Phoenix. And as you can see, it's not a fully autonomous vehicle with no driver, but he's just monitoring how the system works and takes control only in emergent cases. Let's talk about organizer, hardware, software components, and input data. Lyft is a ride-hailing service, competitor of Uber. To tell the truth, I haven't used Lyft yet, but I assume it's more or less the same as Uber. The company uses PyTorch to develop its self-driving cars. The development and implementation of machine learning models is responsibility of Lyft Level 5. It's a self-driving division of this company. Model training and validation is performed on millions of LiDAR images and point of sets that are mounted on the rooftops and in front of the bumpers. And here you can see there are 7 cameras, 3 LiDARs, and 5 radars, which is used for perception. And go next. Let me show you how it looks like in this video, and I'll comment it. The LiDAR and cameras were used to obtain 3D point clouds, which were then processed to detect all the surrounding objects. While perception is considered production ready within the industry, prediction and planning still need improvement. And in the previous competition, live 3D object detection for autonomous vehicles, practitioners were asked to recognize these 3D objects. And it was an important step before detecting their motion in the next competition, which we took part. Lyft engineers were driving along the streets of Palo Alto and scanned the environment around the cars. They recorded a lot of trips to cover very diverse road situations. And the collected data contains more than 1,000 hours of driving in total. So now I give the floor to Artur, and he will tell us more about data and other things. So
yes, thank you, Max.
Yeah.
I will continue in case you've forgotten. My name is Arthur. Hi, everyone, one more time. So as previously mentioned, we have a self-driving car driving somewhere around Palo Alto by Lyft, gathering data about surrounding cars, trucks, pedestrians, cyclists, and other objects. The Lyft perception system outputs 2D images of scenes from the above, so-called bird view. So the meta information about the scenes is collected during the procedure. Most of it for us is coordinates, shapes, velocities of objects on the scene. Main advantage of the dataset is the size. Oh yeah, it's huge. Yeah, so the goal of the competition here is to predict the top 3 trajectories for other traffic participants, traffic agents. The single trajectory is a set of XY coordinates from the bird view, the above one, in the and the competition was required to predict the trajectory for 50 steps, which is worth 5 seconds of time, given 10 steps, of previous historical steps, which is 1 second. The dataset consists of more than 1,000 hours of moving time, which is huge. Lyft also provided us with L5 kit library for processing the dataset, which is basically consists of ZAR compressed files. So due to the high amounts of multimodality and ambiguity in traffic scenes, the used evaluation metric to score the competition is tailored to account for multiple predictions. Since this is not quite obvious about what you're going to do next on the road, go forward, turn right, turn left, or maybe make a U-turn. So the metric was the negative log likelihood of the ground truth data given the top 3 multimodal predictions, and you need to minimize the log likelihood. Yeah, and the data set actually consists of 3 tables, if you could say it this way. So there are more than 170,000 scenes with 25 seconds each long, so it's more than 100 hours of record time. Time frames with time steps, positioning data about the self-driving vehicles, traffic agents data table, which simply describes the coordinates and velocities. So the other positioning information is about the traffic agents on the scene. Now let's talk a little about solution approaches. There was a variety of different models that people used in the competition, with the primary ones being convolutional neural networks only. Of course, when you are given a sequential historical data, you might actually use some of the recurrent neural networks approaches from the something simple like RNN to something more sophisticated like the transformer. Still, what most people seem to have found success in is just directly using the convolutional neural networks. And it's a little bit confusing because typically with images, you might think that you have normal red, green, blue channels. But in this case, we actually have separate channels for the surrounding vehicles for different time steps. So it's not really a representation of temporal nature of data. It's more like a stack of all those channels together with the greatest hope that maybe that would actually work if I simply put it in CNN. Still, most people found success in it, and it turned out that it was not quite beneficial to use recurrent neural networks or transformers or anything like that at all. One more nice approach here to this problem was described in a few papers in the self-driving research area. It was about using the generative adversarial network, so-called GANs, to draw the future trajectories. Since in GANs you're given the noise input, it looked really prominent to predict much more variative trajectories with it. But we didn't actually try it since we only had 1 week to do it, so we simply focused on CNNs because I guess it's more common and simpler and faster to try it first. Yes, so our solution is quite simple, actually. It simply takes time steps of traffic agents on the road as channels. So it's the picture with multiple channels. Also, we take some meta information about the semantic map of the scene, stack them all together, and put it to ResNet backbone architecture. Then we simply pull the results out of it, drop a few layers, a few more layers, and we predict the three trajectories with 3 confidences. So we choose all those confidences and put them to the Kaggle evaluation system. Now, let's talk a little about how it actually looked like. So we have the history of the surrounding vehicles. We stack them all together, we put it all to the model, and we predict the 50 pairs of points, X, Y, for the best trajectory. So if you can see on the left, we simply guess that the vehicle would move forward along the curved way. Let's talk a little about winners, since we didn't win actually the competition, and I wish we did. I wish we had a little more time, a little bit more resources to put it into it. So still, it's quite interesting about what did those guys do. They didn't do quite different things actually. You know, the main blocker here, the bottleneck of this competition, was the ZAR compression data files. You really need the powerful CPU units in order to do the rasterization of those files. And even if you have like the winners of the competitions around 8 E100 GPUs, you would still not be able to use it for full. And so those guys, they simply implemented GPU rasterizer. They made the rasterization from the ZAR files really fast, and they were able to train for more than 4 epochs. Since the dataset is quite huge, we, with their model, haven't even completed the first epoch of time. And so they did. Their best single model was based on EfficientNet architecture. It was pre-trained on 4 epochs just by simply using different resolutions of the input pictures. And eventually they simply ensembled 4 of EfficientNets and got their score. Right. So what did we use as hardware? You might actually think to yourself that, well, I cannot participate in Kaggle since I don't really have no GPUs. Even though Kaggle offers you around 25 hours of GPUs per week, 30, maybe 35, sorry if I don't say it correctly. You do know that you can go to Amazon Web Services, order the server with GPUs, and pay quite a lot of time for learning. But you don't really have to do it, since you have quite a bunch of services like FastAI, which offers you, as you can see on the slide, quite a lot of GPU resources for a really, really low price. But be careful, since not all of those servers are quite reliable. So be ready if something simply dies along the way because of the low price. But we took the risk, and we got our server full of CPU cores, so we didn't really have to work on rasterizer, since we don't really have enough time on that. And we paid around $130 for more than 160 hours of training time, which is cool, I think. Right. So we actually thought that we would end up in bronze, but we jumped a little bit up and ended up in the silver medalist, which is great. And I get my second silver medal, which made me a competitions expert. And I guess that I would only have to get one more gold one in order to become the Kaggle master. Yeah. And I guess that is it. Feel free to ask anything you want. Thank you.
Hello. So I have a personal question.
Yeah.
How did you spend your money? So like, or
unfortunately, we didn't get any money. Only medals.
Okay.
Yeah, only top 5 competitors get the money.
Yeah. And how they spend it, we have no idea.
Yeah, I guess it's probably bro splitted it.
Okay. And what the difference between competition data science and general data science for example, enterprise and production? So there is any difference, or it's like you can just apply your knowledge and that's it? So
it's a whole different world, actually. The precious part of the Kaggle is that you don't really have to care about all the productions pipelines and simply focus on data science. But in the reality, you firstly need to realize what metric do you really want to optimize. And it's not quite obvious because Kaggle Competition simply offers you one, take one and optimize one. But in business cases, you simply need to figure one out, which is not quite easy. Well, secondly, you really need to build quite reliable data pipelines because, well, I think it's obvious why, because you don't really have any possibility to make any data processing mistake here. And it's not just about training models in Jupyter Notebook, it's about serving them to the production, and they have to be fast and reliable. And only then you would be able to do some minor research, maybe in Jupyter Notebook, as we did, and then you would have to migrate all those your results to something more reliable and fast, and do testing and all the extra work.
Okay, and we have one question in Pine. So let me create a banner. Why you choose this architecture? So,
well, simply because it helps. Yeah, we have tried several. We have tried RNNs. It's a completely different approach, and it was actually the first one that we tried, since the data given here is time-ish. But then we simply focused on CNNs, and we used ResNets, efficient nets, quite different. We simply tried different variations of input resolutions, but it all took quite a lot of time of training, and we didn't really have much time. So I would simply say, yeah, it's the efficient net and ResNets mostly.
We Why also thought about GANs, but
yeah,
didn't. Yeah.
So it's why did we choose exactly them, since there's a whole zoo of models out there? Well, it's a Kaggle. You simply read through the competition, you read the forum, you think about what the other guys did, and they tried it, and it actually helped them. And so I figured, like, why not? If it worked for somebody, why shouldn't we use it too?
Okay. So, and you have so there were any chances to win? So if you, for example,
well, let's be honest. When you start participating in the competition, just 1 week before it ends, you have zero chance of winning this competition. Let's be honest. And in order to really win the competition, like the money win the competition, you need to join the competition when it starts. You need to build all the reliable pipelines, like in the future production, if you want to actually pass the solution somewhere else. And you need to do the experiments all the time, every day. And it's actually very nice when you have a domestic cluster full of GPUs, and it's not really very nice when you don't have it. But you can always try to do something nice in the beginning, score high, then simply find your teammates, which might actually have a cluster full of GPUs, and you would be doing quite a lot of experiments with them and share the medal eventually. You did the job, they give you resources. That's how it works.
Okay.
Yeah, and I would like to add, the only benefit here that we joined late, that we could find a lot of interesting discussions and the approaches. Yeah. And it helped a lot to avoid many bad ways to implement our solution.
Yeah, that's true, because when you start, you basically start alone, and you need to fail quite often at the beginning. But
yeah,
still,
the community is very powerful, and I strongly recommend you to watch all the threads and try to find the best ideas and try to implement it as soon as possible.
Okay, is any chance to win, or I don't know, participate without GPUs and paying something to someone, or
yes,
not possible?
I got your question. It depends. It depends. Okay. It mostly depends on the data, on the competitions data. There were quite a lot of competitions which were won by not using neural networks at all. So the guy simply looked through the data, did some deep analytics of the data, and came to a simple classic machine learning solution which scored high. And it's not about simply stacking layers. It's about thinking about the data. But in order to think a lot about the data, you need to join in advance. So also, you actually have free GPUs from Kaggle. I mean, 35 GPU hours per week is a lot. And since when you join at the beginning of the competition, you have like 12 weeks, which is, damn, that's a lot.
So next time we will join earlier.
Yeah, that's a recommendation.
Okay, so okay, maybe you can suggest some I don't know, courses for people who want to start. Definitely Kaggle, not just data science in general, but to, I don't know, participate in such events. Maybe there is some teams, or I don't know, streams or whatever. So how to be involved?
There are two ways of doing that. So the basic way of doing that is simply register in Kaggle, go to the competition, join it, and go to discussions, and simply type a message like, "Hi, I'm the newbie here. What the hell am I supposed to do?" And the community would tell you, they would give you the links to Kaggle free courses about data science, machine learning, computations, and so on. They would help you with a few links to, I don't know, some papers, and they would give you the ground that you would need to work on yourself. And you can always ask anything you want there. For example, if you don't understand some specific things about neural networks, feel free to ask, because it's always a good thing to ask in there, and they would always respond. So yeah, and the more advanced level is to join Open Data Science community, which has grown quite big and international. Yeah, there are always sub-channels in Slack there, which are about some competitions going on there, and you can always discuss, well, actually, there's a difference between discussion of your ideas there and the private sharing. Since the private sharing is quite prohibited on Kaggle, if you really want to discuss some architectural things, I think you should really do it on Kaggle. And so lately, most of the guys in Open Data Science community, they simply tell you to go to Kaggle instead of Open Data Science community, since it's quite easier, because not all the guys from the international data science community are in ODS.
Okay, so thank you for your presentation, so for your experience, for all these interesting approaches. And I think we can go to our next guest. So just a second.
Okay.
Thanks.
Thank you.
Thank you.